All right, so your warm-up says, what would the graph of 4x squared plus 16y squared equals 64 be? What would this look like? Any ideas? Does it match any of our standard forms that we know? No. So we don't know. What could we maybe do? It's definitely not a parabola, right? We can rule that out right away. Oh, okay, take the square root of everything. If this was multiplication on the left, that would work, but you can't really square over up. You can't, if you take the square root of the left, that plus sign would mess you up. Like you couldn't make it 2x plus 4y because of the plus sign. Decent strategy. I don't think it's going to work. Divide everything by 64. Let's try that. Let's divide everything by 64. Why would we divide everything by 64? To get this to be a 1. If you can get this to be a 1, then what is it going to be? An ellipse. Let's see if this is going to work. So what is 4 over 64 going to simplify to? Yeah, I think it's 1 over 16. What's 16 over 64 going to simplify to? 1 over 4 equals 1. That is obviously an ellipse. Good. So this is actually what we'll be doing a lot of next week. Manipulating equations to see what kind of shape it will give you. But this is just a little preview for you. Any questions? All right. Today we are doing what I think of as the most difficult conic section. Hyperbolas. Here is a picture of how you would create one. You take a double cone, slice it with a plane, and you get, it's kind of like two parabolas going in opposite directions. What is this? All right, so here's just a little bit about what a hyperbola actually is. The definition of a hyperbola is similar to that of an ellipse. You might recall that for an ellipse, it's the sum of the distance between a point on the ellipse and the two foci is a constant. For a hyperbola, it's actually the difference is a constant. So let me draw you a quick picture of what this all means. And this isn't super important to have in your notes, but it's kind of important to have a little bit of knowledge of this. So you will have two foci on here. This is saying that if you pick any point on the hyperbola in either one of them and you connect it, if you take this distance, you should get some constant. We'll call it k. If you picked another point, now let's do this one. We'll call this one D3 and D4. You would still get that constant k. So similar to the definition of an ellipse, with an ellipse it was the sum of those distances. Now it's the difference of the distances. We'll give you some sort of constant. That's kind of the formal definition. We won't do a lot with that, but it is kind of where this conic shape comes from. Any questions? Okay, this is the important information that you need to write down. So, as you're writing, it's a little bit different from what you've seen with ellipses. The a squared for hyperbolas is always in the front. A is always in the front. B is always in the back. The thing that's going to be changing is where the x and y are located. So with ellipse, we always put x in the front, y in the back. Now the position of the x squared and the y squared will determine the direction. A is always in the front, B is always second. There is a little bit of information missing from this chart, so I will give you that as well. I forgot to put on here how to find the covertices. You probably could have reasoned through it, but I will write it anyway, because those will be important as well. Another important thing to notice as you're writing all this down, the formula for finding C is different. The way I like to remember it is if you are subtracting in the original equation, you're adding when you're finding C. For ellipses, we were adding and then subtracting, so that's always the opposite. The rest of this, for now, just write it down. We'll go through it as we go through our first example, what everything means. But for now, just make sure you get all this information. So here are some key features. This one, let me get my pointer. This one is when the x squared is in the front. So you can see that your two vertexes are on the x-axis. Our center for everything we're going to look at today is 0, 0, so you can ignore this HK part. But you're going to go A units in each direction. You go B units, up or down. For all of these, we're going to draw in this little box. The box helps us locate our asymptotes. And then once you have your asymptotes and your vertices, you can find your foci, and then you can draw it in. So this is what it's going to look like. Going horizontally, going vertically, it's going to look like this. So again, key features. You go A directions to your vertex. You go B in the other direction, each way. Once you find C, put your foci in. You'll also have your asymptotes when we draw that box, and then you'll put in your hyperbola. Kind of tricky. Again, we will look at plenty of examples. You will feel much more confident as we get moving. All right, so you guys might remember as we were learning the other conics, I'm going to show you the two different types. You don't have to write it down. You don't need to really do anything but listen, and then we'll get into our real examples. So we're going to first look at one with an x squared term in the front. So some key things to notice about this graph is it's going to be horizontal, just like we talked about when the x squared is your first term. You're going to have a horizontal transverse axis. The A is the number of units you're going to go from the center to find your two vertices. The B is the direction you're going to go. Well, you're going to go in the opposite direction. So if you went left or right to your vertices, you'll now go up or down from your center. That'll give you your co-vertices. So let's look at some real numbers and then kind of go from there. So where are my vertices going to be? A units from 0, left or right. Yeah, so 4 units from 0, left or right. Where would my co-vertices be?
So 0, 3.
Good, 3 units, up or down. Now, here's where it gets a little different from all of our other conics. You're going to draw this box in. The main point of this box is so you can figure out where your asymptotes are located. Your asymptotes go through the corners and through the center. Those just help you draw in the hyperbola.
Couldn't you find the asymptote without even having to draw the lines because it says asymptotes is y equals plus or minus b?
Yeah, so you have a formula to find your asymptotes too. Honestly, I rarely use that formula. I usually just kind of reason through it with the box because the A over B in this case is your slope because you go up A units and up B units and then right A units. So, yeah, I do want to see the box though. It is going to help you get the shape a little more accurate. The one thing that we also need to find is the C, and then you would put your foci in as well. All right, and again, C, when you're finding C now, it's a plus instead of a minus with ellipses. But this is basically the gist of it. What are your questions after seeing one example? All right, so before we look at a specific example, let's just discuss what this means. So when the y squared is in the front, what does that mean? It's going to be vertical now, okay? But A is still how far you go to your vertices, and B is how far you go in the other direction. So now A is the number we're going up and down, B is the number we're going side to side, because our vertices are up and down. Yes?
So is this a real example then?
No, this is just another watch and listen and soak it all in example. All right, so let's look at an actual one with some numbers. Again, just sort of hang out, listen, soak it all in. Remember, the A squared tells you where your vertices will be located. When it's under a Y, you're going up and down. When it's under an X, you're going side to side. So for this one, the 3 is your side to side. Those are your co-vertices. The 4 is your up and down to your vertices. So again, since the Y squared was in the front, the A is how much you're going to go up and down in the Y direction. 9, that's your B. B is 3, B squared is 9. That tells you, since it's under the X, how far you're going to go in each X direction.
So the A and B never switch.
The A and B never switch. A is always in the front for hyperbolas. Yep. All right, so now I'm going to draw in this box. The box tells me where my asymptotes are located. So the asymptotes are going to go through this box. Now, normally we would then write an equation in y equals mx plus b form for this. It's just rise over run for your slope. We'll get to that in a second. All right. Next, once you have these drawn in, your asymptotes, we know these are our vertices, so it's going to go through these, approaching the asymptotes but never touching them, through our other vertex, approaching the asymptote, never touching them. There is one key feature that we did not talk about yet, so let's find the c squared so we can graph our foci. You're going to get the same c value on this one. It's the same a and b value. So you need to draw those at 0, 5, and 0, negative 5. Again, those are going in the opposite direction now because of this y squared. When you flip-flop x and y, now everything's up and down except your co-vertices. Those are side to side. All right, questions on this one? All right, this is your first real example. Which way is this one going? Horizontal. It is going to be horizontal, and we call that the transverse axis, the axis that goes through the vertices. The transverse axis is going to be horizontal. I know that because the x squared term is in the front. Now, here's a list of the features we need to find. So we already said we're going to be in the horizontal direction. How many in each direction? 1, right? Square root. So I have vertices at 1, 0 and negative 1, 0. Where will my co-vertices be? Very good. 0, 2, we need to go up 2, we need to go down 2. So 0, negative 2. Once you have your vertices, in this case they're side to side, your co-vertices, in this case those are up and down, we are going to draw in this rectangle. The whole point of that rectangle is to locate your asymptotes. Now, on quizzes and tests, you need to tell me the equation for the asymptotes. It's always y equals mx plus b. You just need to find the slope. When it's going through the center at 0, 0, your b will be 0, so you don't need to worry about that. Your slope in this case, you'd go up 2 over 1. For the other one, you'd go down 2, right 1. So positive 2 is the slope for this one. Negative 2 is the slope for this one. Or you can just remember, in this case, it's plus or minus b over a times x. What are your questions so far? All right, one last thing I want to find are my foci. I need to find c squared. So I'm going to do a squared, which is 1, plus b squared, which is 4. When you add those, you get 5. When you take the square root of 5, you get 2.2. So I am, again, going in the horizontal direction. So I'll have 2.2 comma 0, negative 2.2 comma 0. Now I'm going to draw in the actual graph. Remember, it's going to be going through the vertices, approaching the asymptote. So the asymptotes kind of direct you on how wide each one needs to be. What are your questions? You can see how these are definitely harder than the rest. Questions? All right, here's example 2. All right, which way is this one going to go? Up and down, yes, it's going to be vertical. So my transverse axis is vertical, meaning that my vertices will be up and down. So what is my A here?
9.
A squared is 9, so it's A. 3, good. So I need to go up 3, and I need to go down 3 for my vertices. How do you tell whether you're going up or down? Where the y squared is compared to the x squared. So when the y squared is in the front, your vertices are up and down. When the x squared is in the front, your vertices are side to side. All right, so my co-vertices are now in the left and right direction. How many units in each direction? 4, good. Okay, once you have those 4 points, I'm going to draw in my box. The whole point of the box, or the rectangle, I guess is the more technical term, is to find these asymptotes. The asymptotes are going to go through the corners. So I'm going to go up 1, 2, 3, right 1, 2, 3, 4. So I know my slope of this one is going to be positive 3/4. The slope of the other one is going to be negative 3/4. So plus or minus 3/4 x will give me my asymptotes. And again, that's just slope-intercept form. Y equals mx plus b. We're going through the origin, so we don't need a b. This is our slope. All right, how do I find my foci? Yes, c squared equals a squared plus b squared. So a is 9, b is 16. That would give me 25, and the square root of 25 is 5. So again, we're in the vertical direction, so those are vertical points. So up 5, down 5, and then once you have those, you can draw your hyperbola. You can see how the asymptotes are a little wider, so that means our graph's going to be a little wider. Remember, those are just a guide on how wide you need to be. What questions do you guys have on example 2? All right, which direction is this one going to go? Horizontal. How do you know it's horizontal? The location of your x squared term. Good. So, again, whatever number is underneath the first term, that's your a squared. That tells you how far in this direction you need to go to get to your vertices. So now we're going in the x direction since it's horizontal. So where will my vertices be located? Yeah, 2, 0, negative 2, 0. You're going side to side 2 units because it's the square root of this term. And it's under the x. How many am I going to go in the y direction to get my covertices? How many? 3, good. So I need to go up 3, I need to go down 3. All right, you can draw on your box. Remember your box, I keep calling it a box. It's really a rectangle. Your rectangle is just to guide you when you are drawing in your asymptotes. So it looks like this one's going to go up 3, right 2. So my slope is going to be 3 over 2 and negative 3 over 2. So plus or minus 3 over 2x. Of course, that's a y equals because it's in y equals mx plus b. Draw those in. How do I find my foci? C squared equals? A squared plus b squared. A squared is 4, b squared is 9. So that would give me the square root of 13. When I go to solve for c, the square root of 13 is approximately 3.6. Again, those are in the same direction as your vertices, so that will be my x values. Y values are 0. Once you have all that information, you can draw in your curves. Remember, they need to go through the vertices and approach the asymptotes. Questions on number 3? All right, this is actually our last graph. Then we're going to look at some equations. Which way will this one be? Vertical, good. It is vertical because the y squared term is first. Look under that term to tell you how far in each direction you're going to go. So we are going vertically, and we are going up and down 5 units. Now, this graph, I couldn't really fit it on there, so I counted by 2s, so it looks like it's 2.5, but it's really 5. So just be aware of that. Covertices are how many units left and right? 3, good. That gives me 3, 0, negative 3, 0. It's time to put that box in. Rectangle. What's the equation of the asymptotes going to be? Y equals plus or minus 5 over 3. Good. 5 over 3x.
Oh, you said you counted by 2s or something?
Mm-hmm. Counting by 2s, yep. All right, foci, we need to do c squared equals 25 plus 9. That gives me square root of 34 when I solve for c. That's approximately 5.8. Those go in the same direction as your vertices, so those will be y values, 0, 5.8, 0, negative 5.8. So you can see this one's a little skinnier than our previous examples. What questions do you have? All right, let's look at number 5. All right, so now you're given some key features. You're given the foci. What does foci give you, A, B, or C? C. So we know that C is 5. And we know our vertices. What do the vertices give you? A. Good. And both of those, the foci and the vertices, are left and right of the center. Do you all agree? So which term needs to be in the front? The x squared term. Good. Now, I just need to find b, right? C isn't actually even in the equation. It's just going to help me find b. So I need to find a. I already have it. Need to find b. So I have 2 squared plus b squared equals 25. That's the c squared. When you solve for b squared, you get 21. Take the square root of both sides. You get that b equals square root 21. So I know a, it's 2. I know b, it's square root 21. And I know that x squared needs to go in the front. Once you have all those things, you're basically just plugging in. So you got 2 squared, square root of 21 squared, x in the front. You have a minus sign because it's a hyperbola and not an ellipse. Equals 1 because that's the standard form. And then you're basically just simplifying. 2 squared is 4. Square root of 21 squared is just 21. What are your questions? All right, here's number 6. Again, they're giving us the foci, they're giving us the vertices. The foci gives us C, the vertices give us A, but we need to find B. You should also, as you're going through this, notice that those are both in the X position, which means we're going to be going side to side here. There's going to be a horizontal, so you need your x squared in the front when you start writing your equation. But back to this, finding the b. A is 2, 2 squared is 4, plus b squared, that's what we're looking for, equals 9. When you solve for b here, you get the square root of 5. We already said this is going to be horizontal, so x squared needs to go in the front. 2 squared goes underneath the x squared. Square root of 5 squared goes underneath the y squared, and then you're just simplifying. Questions? All right, let's look at one that goes in the other direction, and then we'll be done. So you can see here, these are all in the y position, meaning we're going up and down from our center. So when I write my equation, what needs to be my first term? X squared or y squared? Y squared. Very good. That's really the only difference here. We're still using the foci to find the C, the vertices to find the A, solving for the B. The only difference you'll see now, the y squared is in the front. And the reason is because from the origin, from our center, these points are all up and down. All right, A still goes in the front, though. That's a common mistake here. Just make sure that A for hyperbolas is always your first term's denominator. B squared is always the second term's denominator, and then just simplify. Any lingering questions? Notice I have added 2 problems so you could practice writing those equations. So make sure you do number 57 and 59. You have all of class tomorrow to work on this homework assignment, but for seniors, that's not a lot of time. So make sure you take a glance at it tonight. Bring any questions you have tomorrow. We can work through them on the board.